All right, welcome back. Hope we had a good quick break. We are on class number 4, and we are on module number 2. We're going to give some more functionality to our functions now and make them a little bit more useful. So jumping into our Jupyter Lab notebook here, I want to point out functions can take parameters. So I can pass things into functions so they can manipulate data that I'm providing to the function. So you'll see how useful this is here in a second. We can also define default values with functions. So I can actually, if they don't provide something, I can provide a default value for that. Let's go ahead and take a look using our previous example where we had the average. I'm going to grab this example here. And I created in the function the list of items that I want to pass in. Instead of defining it there, what if I have them pass it in? So let's now take this out of our code. So now we've defined our function. If I run this code, good. Python's now got it in its memory. Now let's go ahead and actually instantiate the function, or actually what we call calling the function. So I'm going to use the word average. I'm going to do open parentheses, close parentheses, just like we saw before. But because the average function takes some parameter, I have to pass the parameter into the function that I'm trying to call. So in this case, I want to do a list of numbers. So I forgot what the list of numbers was, so we can keep it consistent. I will pass this list of numbers. And now when I run the code, it gives us that same average. What if I change my numbers? So in my code, the first time through, I had set one set of numbers. Now I got a different set of numbers. So now I get a different average, and the function didn't change at all, right? It's the input to the function that changed. So what if I call it a couple of times? Let's call it, and let's just give it new numbers every time. I'll just come up with some random extra numbers here. Say 5. We'll make this 8, just so we get some different results. So now you'll see that I get my different averages, and I only had to write the code one time. And if there's a flaw, I have one place to fix the flaw. But I'm able to use this several times in my code, throughout my code. So that's how we can pass back, or sorry, we can pass values into our function. We can also return values back from our function. In fact, if I look, I can see that my function right now already is returning something to me. I can assign it to a variable. Let's do my, my var. We'll use that as an example here. And I'm going to say it's equal to average. And I'm going to pass in a different set of code. Instead of passing in square brackets, I'm going to pass in a tuple. And when I run the code, it gives me the result even if it's a tuple. So that's a nice thing about typing in Python. Remember I said it was dynamic typing? Anything that's iterable, I can iterate over, I can put in as a parameter into this item as long as they equate to number types. So in this case, these are all numbers. I could do floating points. I can even do a mix. I can leave these as integers and these are all floating points and go ahead and run that. And you'll see that it works just fine as well. So now, look at how this call is made versus the previous call. Right here, I'm using square brackets, which intuitively makes sense, right? Because we know that's a list nomenclature. Like, how do we define a list? We use square brackets. Well, how do we define a tuple? Is we use parentheses. So how do we call a method? We use parentheses. So it gets confusing, but I want you to understand what's happening here. The outside parentheses are parentheses for the function. The inside parentheses are the parentheses for the tuple. If I got rid of the inside parentheses, what's going to happen now is I only have one input, right? List of numbers, and I'm passing in every value as a comma is a new value passed in. So when I go ahead and run this, I'm actually going to get an error, a type error. It was expecting one item, just being a list of numbers, and it got 1, 2, 3, 4, 5, 6, 7, 8 items. I could fix this. Let's go ahead and comment this out. And I could say, I don't know, number 1 and 2 and 3. Let's just do 3 numbers just to show you the point. So I don't have to go too far into depth. So I'm going to pass in 3 numbers, 1.5, 22.4, and 61.43. I'm going to get it as 3 different variables. So let's go ahead and define this to be a list. So I'm going to say in1, 2, and 3 are going to get put into my list. And now my function will work just fine because I'm passing in 3 separate variables. Now I tend to like passing in list a little bit better because with a list I can have any number of values in the list, right? Here I had 3, here I had 6, here I had 1, 2, 3, 4, 6, I had 8. So I can have a list can be dynamic in its size. So I'd rather have a list. So let's go back to how we had it and copy this code, paste it down here so we can kind of keep the concept alive, and let's go back to our passing in a list of numbers. So now we're going to go back to making this a tuple, and it should function now just fine. Okay, I also returned it as nyvar instead of myvar. Now I got it as myvar. Let's see what this function gave back to us. Let's go ahead and print the type of whatever the variable was that it gave us back, so we can find out what data type it returns by default. It actually gives us back a thing called none type. So by default, if I don't do anything, functions are going to return back a thing called none type. But if I want to give it back as an actual item, I could give it back with the return statement. And I want to give back the actual average. So I'm going to give it back as the count variable divided by the size variable. And now when I run this code, you'll see that it's of type float. And if I actually print it out, we now see we get the actual average returned to us. So now I don't typically want to put print statements. I mean, you can put print statements in your function, but that's not the norm because that could dirty your output. The better approach is to do something along the lines of this, right? And then instead of doing count divided by size, because those don't exist in the main code, those exist in our function, I can print out myvar. And I don't need these 2 statements. We'll go ahead and print that out, and you'll see that we get the same functionality, but it's a little bit cleaner, right? Because 1, we can dynamically pass in how many items we want, and number 2, it's going to return the result. Now I can print the result, I can store it in a database, I can do multiple things with it. Before, it was always just printing it out. Now it gives the programmer the ability to decide what they want to do with this result value from our function. So what I want to take away is we can pass parameters in. We can pass them in with comma separated if I want to have multiple parameters. I can pass them in as a data structure. Now we see the value of why we wanted to learn data structures, right? Because data structures let us store and manage data nice and efficiently. And then we can also return values out of our function. So we can use that return statement to reply back and give back the main code the result of what you did in your function. Now, if I return back the average, you can also see what data type it is. myvar, and I want to see the data type. And you'll see that it is indeed a float variable, and we can see that right here. I can pass back multiple values if I wanted to. I can pass back, this is the average, then I can pass back the sum, and then I can also pass back the size as a comma separated thing that I'm returning. So this is object 1, that's object 2, that's object 3. What I want to probably do here is put a comment, oops, not $, £, and say returning average, sum, and size. So that way I can look at my my notes and kind of see what I'm doing here. So now my var is going to be a tuple when we get it back. And let's go ahead and see how that works. And you'll see that my var is in fact a tuple, and I get back all 3 results. If I want to do a tuple decouple, we can automatically break them down into multiple variables. I could do avg, comma, sum, comma, size. And now I can reference, I should probably have, let's undo that real quick. Let's copy this and create a new block of code here and paste it in with that. Now let's do our tuple decoupling. Average, sum, and size being tuple. Oh, I can't use the word sum because that looks like it's a reserved word. So we'll use summation. I'm doing my tuple decoupling, and now I can use these variables in my, I don't know, we'll see what the average is. I can run that. I could also say the total is, and so now I have a little bit more flexibility, right? I can return what I want to return. I can return multiple things. And by default, if I comma separate them, it's going to return them as a tuple, in which allows me to do tuple decoupling. So I can put them into individual variable names. This is very convenient if I'm doing, I don't know, like vector math. I can get the magnitude as one parameter back. I can get the angle as the other parameter back. So I can then tuple decouple that. If I'm doing the quadratic equation, I can get back I don't know, different results, the x, y, and the z, that kind of stuff. I can get radians versus degrees. So however I need to return my data back to myself, I can just do a comma separated result that way. Okay, last thing I wanted to go over is default values. Oh no, I have 2 more sections. I got function scope and default values. Let's talk about defaulting values into our functions. Let's define a function, and we'll call it calculate, I don't know, BMI, body mass index. Some of the parameters that you're going to need for BMI, and I don't actually know the formula, so I'm just going to do a dummy example. But you might need to know height. You might need to know weight. And you might need to know gender, because I think gender is a parameter in our body mass index. Then I'm going to do my doc string, my documentation string. Calculate BMI via some method. And I can do another doc string saying to do get the code working, because I don't know what the BMI formula is. But my point here is I want to just show you how I can default this with a value. So we're going to say the default is male, and I'm just going to print everything out. We'll just say height, print, weight, and then print gender. And now we're going to go ahead, now that I've got it defined, let's go ahead and call it. So calculate BMI, and I need to put in a height, we'll say 70 inches, 175 pounds, and I'm going to say female, and I'm going to go ahead and run, and you'll see that in fact it does. It prints out the height, weight, and the gender being female. But I've defaulted it to be male, so if I don't pass a parameter, like I leave it blank, you'll see how it defaults the value to be male. Now I could say the default weight is 200 pounds, so, and then if I don't pass in a weight, or actually I'll leave it just like that, right? So now if I remove the weight, so say 70 inches, now I get male and 200. So I can leave default values here. I start at the rightmost parameter. So in this case, that's gender, right? That's the third parameter that I'm taking in my calculate BMI function. I can make that an optional parameter by using the assignment operator and giving it the default value. Then, if I've done that, I can then go to the next variable and decide whether or not I want to give that a default value. But as soon as I take a variable and don't give it a default value, I can no longer make the next variable to its left have a default value. For instance, if I remove our gender male being equal and I try to run this, we'll actually get another type of error, which is called a syntax error. I have to start from the rightmost parameter that I'm passing in and give it a default value and work my way back towards the to the left. So if I stop at any which variable and don't give it a default, I can no longer give other variables to its left a default value. So we'll put that back, just so we have a working function here, just to show you how that works. So that is default values, and they come in very, very handy. We can actually, let's create a new block of code, and we can go back to our original example way back up here. Where was our, I leave that up here, yeah, we'll use this one. Come back down, put our code there. Remember how I didn't pass anything in, and I had the variable predefined here? Well, let's put this in our function definition. Remember, the function definition is that first line of code that's not indented. This is our definition. Now, if I choose to call the definition, I can just call average by itself, or I can call average with a list of my own. Right? And I'm going to get both will work. The first one is averaging based on this value for my list. The second one is averaging based on the values that I put in here. So that is default values, and that comes in very handy, but just got to remember that it starts at the far right-hand side of all your parameters that you're passing in, and as soon as you stop defining a default, you can no longer assign a default for the other parameters. Last section for this module is talking about function scope. If I define a variable inside of my function, we call that a local variable. And anywhere outside of that function cannot access that local variable because it's what we call outside of scope. Global variables are defined without indentation, so they don't have 4 spaces, right? They're all the way to the left-hand side of your screen. Those are considered global variables, and those can be accessed anywhere in your code, including other functions, other code blocks, so they can be accessed from anywhere. Let's take a look at that, right? We'll come up with our, we're going to define, well, we'll just come up with a variable first. Let's say x equals 10. Now let's define multiply by, oops, I forgot I'm doing by 10. I want to pass in a variable. We're going to say base. That's going to be the base number. Then I'm going to do colon. In fact, we're going to say multiply by x instead of by 10. Here, I'm going to return base times my x. And let's now call that function. And I'm going to put in the value of 5. And we get the result of 50, because 5 times the value of x is 10, that is 50. Now, x is considered a global variable. In fact, I can print x right here. And you'll see that I'll get a 50 and then a 10. No problem. I can access x anywhere in my code. If I define x inside my code, I can no longer access it outside of my code. Well, with a caveat, I do need to restart my kernel because it's in the kernel's memory space that I defined x already. So let's go ahead and restart kernel and clear all outputs to do this example. Okay, what's going to happen here? It's going to define multiply by x with one parameter called base. And that's the first line of code. That's the only thing that Python interpreter's read so far. Then it skips down and says, okay, now I want to run that block of code, which starts here. It says x equals 10, returns back base times 10, and gives me that result. Let me actually print that result. Then I'm going to try to print the variable x. The problem is, oops, there we go. X is defined in the scope, remember that block scope, of our function. So therefore, x doesn't exist globally, and I cannot access it down here. See, it says x is not defined. Now there is one workaround for that. It's not really a workaround. It's an intentional way to do this. There's a global keyword, and I can type global x, and what that does is it says this variable needs to be accessed everywhere, make it a global variable. So now when I run it, oh, global x, then I have to say x equals 10. It's 2 lines of code. I have to declare it global, then I have to assign it. There we go. Sorry about that. It's been a while since I've done that global variable. It's not really used that often. That's partly why I haven't really done it, and that's also not my coding style. I'd rather keep variables tightly coupled to the function that they're in, because you don't want to mess with the integrity of somebody else's variables. If you keep your variables local to your functions, then you don't run the risk of overriding somebody else's variables or having them override your variables. So I try to keep everything in a tight scope as possible, such as that it's only defined in the function. Okay, but I can also override the value. In fact, this is another thing we can try here. We're going to say a global x equals 50. Then I'm going to create x equals 10 inside my function. I'm going to print the base value times x, here x equals 10, and that's going to return back 50. Then I'm going to print out the value of x. This x is local to my function. This x is global. So when I get to this print statement, it's going to print the value 50, not the value 10, because I overrode the value here locally only, not globally. Now here's a fun trivia. I learned this the other day when I was writing code. I made a code mistake, but it's worth pointing out because of the way that Python treats local and global variables. If I did something like, let's say return result, is equal to base times x. And then I want to return base result here. It's going to function just as we think, right? It's going to take this global x of 50, multiply it by 50, and I'm going to get 250, and then the value of x locally. But what if I later, after I've used the global variable x, define x in my function and just say x is equal to 10? What happens here is when it does this definition, it says, oh, there's a local variable x, but here I'm referencing the global one, and it's got a conflict with this. So I'll actually get an error. Here's another type of error that we haven't seen yet. Unbound local error. Cannot access the local variable x because it is not associated with a value at this point. So it's trying to use the local variable x here, but it has not been defined yet because it's down here where it actually gets defined. So you got to make sure you define your variables before you reference them if you want to use local variables. So now it should work just fine. There we go. Okay, lots of takeaways from this lecture. We can pass in parameters, and we saw that we could pass in individual things separated by commas, or we said we could pass in a complex data structure such as a list. A list has that more flexibility because it can grow dynamically. I could also pass in a tuple. Whatever data structure that I want to pass in, I can pass in here, as long as I don't do anything outside of the bounds of what the calculations are trying to do. In this case, they're assuming it's a list of numbers, therefore I'm doing number type math on it, like adding them up. If I pass in a string, that's going to cause errors because I can't convert from strings to numbers on the fly like that. You have to explicitly tell it to convert those. Okay, so I can pass in one or more parameters. I can also do default values where I assign the default values. We start on the right-hand side. The rightmost variable has to be the first one that we define with a default value. And then if we do this one, we can do its neighbor. And if we do its neighbor, then we can do the first one. But as soon as we choose to not do one here, and I try to do height of, we'll say 70, that'll give us the error, right? So we have to start from the rightmost, work our way back. Got that done. What else did we talk about? Lots of stuff, right? Return statements. That's how we get value back from our function back to who called that function. And so we saw how we did that here. We did that two different ways. We did it with tuple unpacking. Where did I do my tuple unpacking? Here we go. Tuple unpacking, where I pass back three different values, right? The average, the sum, and the length of the thing. And so I unpacked it here to three separate variables. I could have unpacked it as a tuple and then used my square brackets to reference into that tuple, or I can do it the more intuitive way, which is do a comma-separated variable names. Then we looked at, what else did we look at? Oh, scoping. Yep, that was the last thing. So we have this concept of local variables and global variables. And they can have the same name, but they don't step on each other. So here this x is available anywhere in the code that you want to use it, except for, since we defined it locally here, I cannot reference it. Once I've defined it locally, it's hidden this variable x from my use. I can only use the local variable inside the function here. So you want to make sure that you're keeping your variables tightly controlled, and you don't want to have accidental overridden values or changed values. So I try to make sure that I'm keeping my variables local scope if possible. And then if I want to return it back, I return it back as a tuple. That way it's immutable and they can't change it on me. So that's how I tend to define and work with my functions, right? I tend to try to pass it back as a tuple. In fact, I would typically do it this way, right? So that way now it's wrapped as a tuple and returned back as a tuple. In fact, if I do the type, in fact, it's actually not what I would do, but we'll show you one more time. Yeah, because it's actually, I need to tell it that it's a tuple, so I have to do a comma. There we go. So now it's a tuple. The good news is that tuples are immutable, but so are integers. So I don't really need to do this because integers are also immutable. All right, with that, that's all we got for this lecture. And next one, we're going to talk about using other people's code that they've already written. Get lots of functionality from what other people have already done, so why not leverage it? All right, I'll see you in a few minutes. Take a good break, and I'll see you back here.